Here is the second handout that you received in the classroom earlier this week. We'll take a little time to go through it. How long will it take a $1,000 investment to double in value if the interest rate is 6% compounded continuously? There we go. Now you can see everything I wrote in the margins on the left. So what I've written down in the margins on the left are the equations that drive these scenarios. When we have continuously compounded interest, we are doing population growth. It's just that our population is of dollars rather than of bacteria. So this equation drives the whole thing. Now, when we're not doing continuously compounded interest, we're doing periodically compounded interest. We have to fall back on the more financy type of equation that you were provided, and we'll practice with each. So how long will it take a $1,000 to an investment to double in value if the interest rate is 6%? Well, let's load this up. In this case, we happen to be given our growth constant K. The growth constant, quote unquote, is the interest rate. And in this case, we're just told what it is, so we don't have to do that calculation off to the side first. We can just dive right in. We are looking for a $1,000 investment to double. That means if we start with an initial amount of 1,000, we want that to turn into 2,000 by exponential growth. The interest rate is 6%, which is 0.06 times t. Take the log of both sides. Oh, bad idea. What should I do first? I should probably divide by 1,000 first. So let's rewrite this as 2 equals 1e to the 0.06 t. Now let's take the natural log of both sides. I knew that was getting messier than it needed to be. When we take the natural log of the right-hand side, the log and the e do their thing. And so t would be natural log of 2 over 0.06. And I actually have this number already at hand, and that turns out to be about 11.55 years. Switching back to periodically compounded interest, how long will it take a $1,000 investment to double if the interest rate is 6% compounded annually? Well, now we're using this one, but our initial amount is 1,000. Our interest rate is 0.06. It's compounded annually, which means it's compounded once per year, which means that parameter n will be 1. And then we're going to solve for t. So we want a net result of 2,000 out of an initial investment of 1,000. Again, the interest rate is 0.06. The number of compoundings in the course of a year is n, which is 1 because it's compounded annually. And then up in that exponent, we will have n times t, or 1 times t. Dividing both sides by 1,000, we get 2 on the left. See, I remembered to do that first this time. Over here, this is just 1 plus 0.06, which is 1.06 raised to the t. And so we can take the natural log of both sides. We'll get natural log of 2 equals the natural log of 1.06t, but the reason we like that is the t gets to come down in front. And solve that for t. Calculate log of 2, calculate log of 1.06. Divide the log of 1.06 over to the left-hand side, and we will end up with a t value of about 11.9 years. So it looks like it takes a hair longer for our investment to double if it's compounded annually rather than continuously. So continuously compounded interest looks to be better. Part C asked, would either of your answers change if we made a $10,000 investment? In other words, does the amount of time it takes our investment to double change based on how much money we put in? And the answer is no, because the answer to this question is no, definitely not. Take either of these equations. When you're looking at doubling of your investment, whichever right-hand side we're using, whether it's exponential decay or exponential growth. I hope it's not decay. My bank account is exponential decay, but that shouldn't be the standard. If it's exponential growth of money, continuously compounded interest or if it's periodically compounded. Whichever right-hand side you're using, if you're looking to double your investment, whatever your initial investment P0 is, the left-hand side would be 2 times that amount. So like 1,000 to 2,000. And whatever that P0 is, the first thing you'll end up doing is canceling that right out. So the amount of time it takes to double your investment is independent of how much money you start with. Okay. Part D, this is just sort of a side note. There is a rule of thumb in economics called the Rule of 72 that says if your investment is earning an annual percentage of interest, then doubling your investment will take about 72 over R, where R is your rate, in terms of time. And so 6% interest, we would have this. In this case, the R value is at 6. So this sort of notation right there, the R, the interest rate we're talking about, for the rule of 72, we would not convert it to 0.06. So 6% is just discussed as 6 in this context only. Up here, we'd change it to the decimal version. Well, this turns out to be 12. So the rule of 72 says with a 6% interest rate, we should expect it to take about 12 years for our interest rate, or for our investment to double. That's more like our result here about annual compounded interest. So the rule of 72 is just a rule of thumb. It's not totally accurate, but it gives you something kind of like what annually compounded interest would return. It's certainly a much simpler calculation. Okay, now go make money.